So in this video, we're going to learn the concept of trigonometric identities. Now in previous classes, we have studied the concept of algebraic identities. So recall algebraic identities. We'll take an example of a really simple one. For example, we learned that a plus b the whole square is equal to a square plus b square plus 2ab. So this over here is an example of an algebraic identity. Now what exactly is an identity? It is basically something which is true for any real number. That means whatever value of a and b I take over here, this identity will always be true. Let me take an example. Let's say I take a as 5 and I take b as 3. So I'll solve the LHS separately. So LHS we have a plus b the whole square. That is a 5 plus b 3 the whole square. 5 plus 3 8 square. That is 64. Now let's solve the RHS. So we have a square plus b square plus 2ab. So what is a? It is 5. So 5 square plus b square 3 square plus 2ab. So 5 square 25 plus 9 10 into 3 30. So 25 plus 9 34 plus 30 that is 64. So as you can see, LHS is equal to RHS. So no matter what real numbers you take for a and b, this will always hold. That is why it is an identity, something which is always true. So this was an example of an algebraic identity. Now similarly, we have trigonometric identities. So basically we'll start off with three simple trigonometric identities. So I'll write the three trigonometric identities over here. The first one is sine square theta plus cos square theta is equal to 1. So theta means we can take any angle over here. So sine square of any angle plus cos square of the same angle is equal to 1. Let me take an example. So let's say I take theta as 30 degrees. So let's say theta is equal to 30 degrees. So we have sine square 30 degrees plus cos square 30 degrees. Right? So recall, what is sine 30 degree half? So sine square means sine 30 the whole square plus cos square 30 means cos 30 the whole square. Cos 30 is root 3 by 2. Root 3 by 2 the whole square. So 1 by 4 plus 3 by 4. That is equal to 1. See? So sine square of any angle plus cos square of the same angle is equal to 1. So this over here is the first trigonometric identity. Similarly, we have 1 plus tan square theta is equal to sec square theta. Right? So that means if I choose any angle over here, 10 degree, 100 degree, 1000 degree, whichever angle you want. So 1 plus tan square of that angle is equal to sec square of that angle. You can verify just like this. And the third one is 1 plus cot square theta is equal to cosec square theta. So these are the three basic trigonometric identities we're going to begin with. I repeat once again, what is an identity? Something which is true for all values of the variable. Here, what is the variable? Angle, right? Now remember, these two angles have to be the same. You can't take sine square of 30 and cos square of 60, no, same angle. So sine square of any angle plus cos square of the same angle is equal to 1. Next, 1 plus tan square of an angle is equal to sec square of that angle, and 1 plus cot square of an angle is equal to cosec square of that angle. So please remember these three trigonometric identities. Sine square theta plus cos square theta is equal to 1. Here theta is basically a variable which represents an angle. So sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is cosec square theta. So these are the three basic trigonometric identities. So previously we have seen the three basic trigonometric identities. Sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. So let's study these identities in more detail. So see, I have sine square theta plus cos square theta as 1. So what I'll do is, I'll take cos square theta over there. So what do I get? I get sine square theta is equal to 1. Cos square theta is being added. So on the other side will be minus 1 minus cos square theta. Right? So if I want to convert sine square theta to cos square theta, I can write sine square theta as 1 minus cos square theta. Conversely, I can write 1 minus cos square theta as sine square theta. Similarly, keep cos square theta over here, take sine square theta over there. So we have cos square theta is equal to 1. Sine square theta is being added here, other side subtracted. 1 minus sine square theta. So either replace cos square theta by 1 minus sine square theta, or 1 minus sine square theta by cos square theta. Is this clear? Right? Next, similarly, we'll do the same thing over here. So what I can do is I can take tan square theta over there. So we get 1 is equal to sec square theta minus tan square theta. I repeat, take tan square theta over there. So we get 1 is equal to sec square theta minus tan square theta, or take 1 over there. So we get tan square theta is equal to sec square theta minus 1. Is this clear? Similarly over here, keep 1 over here. So we have 1 is equal to cosec square theta, cot square theta is being added here. Other side will be subtracted. So cosec square theta minus cot square theta. Now keep cot square theta over here. So we get cot square theta is equal to cosec square theta minus 1. Is this clear? So all you have to remember is these three basic identities. The remaining you can always derive. Is this clear? So just remember these three identities and learn how to derive these. Is this clear? Now, if you notice one thing, in all the identities, all the trigonometric ratios are in their square form. See, sine square, cos square, tan square, sec square, cot square, cosec square. So whenever I have to apply these identities, I need to have the trigonometric ratio in the square form. I repeat once again, in all the identities, each trigonometric ratio is in the square form. See, sine square, cos square, tan square, sec square, cot square, cosec square. So whenever I'll be using these identities, ensure the trigonometric ratio is in the square form. Is this clear? So these are the three basic trigonometric identities, and these 6 we can further derive from these 3. Is this clear? So please ensure you remember these 3 identities and you're comfortable in deriving these 6. Is this clear? So these are the 3 basic trigonometric identities. So we're done with the learning part of the concept. Now we'll practice examples on how to use these identities.